So last week we talked about scope management, and here's that knowledge area in the process matrix showing scope management. And in the ITTO diagram, we saw the requirements coming out of the process, collect requirements, and then we saw where we had to make decisions within defined scope to decide which of those requirements are going to make the cut and become a part of our project scope. Not every requirement that was articulated is necessarily going to make the cut. And this whole line of thought of establishing the requirements up front makes a ton of sense when it's feasible. And this is what's typically meant by traditional project management, where the cost of change is high and changes that surface, new requirements that surface late in the game are much more difficult to accommodate, or perhaps even impossible to accommodate. And so it's really important to establish all those requirements up front as much as possible. But this whole line of thought falls apart. Sometimes, some situations, some projects just don't lend themselves to this approach, and we need some alternate approaches. And this Stacy matrix is one framework that can help us think through that situation as to whether we have a project which is predictable, where we can establish the requirements up front, or do we have a project where that's just not realistic and we need to look for a different approach. So here we're showing technology on the x-axis and requirements on the y-axis. And if our technology is very uncertain and our requirements are very uncertain, then we're in the upper right in just complete chaos, and we don't know what the heck we're going to do. As we move towards the lower left, we're moving through these zones. At the extreme lower left, the technology is completely familiar to us, well established. The requirements are very readily defined up front. And so that's our simple project where traditional project management can work. And then a little bit further up and to the right, in the complicated zone, things are still predictable, but it's very intricate. And so we need deep subject matter expertise to navigate the situation. But the predictive traditional project management approach can still work there. And then further up and to the right in the complex region, we have a situation which is just too unpredictable, and the traditional project management, the predictive approach, just is not going to work, and we need to find a different approach. And that's where the different flavors of adaptives come in, iterative and incremental, as well as agile and hybrid. So technology on this axis and requirements on this axis is certain parameters. In certain projects, you might see other parameters that are useful to think about. But this Stacy matrix is a handy way to think about things, and it is something which has shown up on the test recently, and it is mentioned in that Agile Practice Guide, that little 1/4-inch thick book that comes wrappered with the PMBOK guide. So it's good to be a little bit familiar with this framework. We saw how the tool or technique of prototypes within collect requirements can be really helpful as we're navigating through these more adaptive project life cycles. That'll support communicating our design direction with the client as we go through design iterations. And other words we might hear besides prototypes are wireframes or storyboards. Amongst the Agile practitioners, you might even hear the term low fidelity wireframes, which is just to emphasize that they're not super polished. The intent is to communicate design direction. The intent is not to be winning a beauty contest for the most aesthetic, polished diagrams. So whatever you call them, these prototypes help communicate design direction and help you get feedback from the client as you go through that design journey. Instead of working in a vacuum all by yourself and over designing it without any feedback at all, spending 18 months creating a shiny apple, handing it to the client, and having them puke all over it. That's not what you want to have happen. So the prototypes helps support this design iteration, communication with the client as we evolve a design solution together with the client. Just quickly reviewing the definition of a requirement in the PMBOK guide. In the glossary, you'll see this definition: a condition or capability that is necessary to be present in a product, service, or result to satisfy a business need. And that definition seems pretty decent to me. And now thinking about the predictive versus the adaptive project management life cycles. In the predictive, we're going to be eliciting requirements up front primarily, and then eventually we're going to get to a point where the cost of change is getting quite high, and we're going to become much less interested in hearing anything about additional requirements. Whereas in the adaptive project lifecycle, we're going to be eliciting new requirements continuously. We're going to do everything we can to stay responsive to new requirements. And there's two flavors of adaptive, talked about in the PMBOK guide in the early chapters: iterative and incremental. And it's really important to be crystal clear on what's meant by these terms. And this can help. So here I'm showing degree of change on the x-axis and frequency of delivery on the y-axis. And this is a diagram you'll see in the Agile Practice Guide that comes wrapped with the PMBOK guide. So in the lower left, we have our predictive project. For example, maybe we're building a new production line. And it's very similar to other production lines we've built in the past. So we're very familiar with this type of project. We can very realistically establish the requirements up front, create the design, develop a schedule and a budget, plan the work the plan. And then in the upper left, we have the incremental. So maybe we're opening up Best Buy stores around the country. And this year we plan to open 12 stores in 12 different cities. And the design is almost identical from store to store, but each store is a distinct project. It has a different building inspector and slightly different local building codes and so forth. But the degree of change is quite low. All the designs are very, very similar. So what we're really doing is chunking out increments of delivery, increments of value over the year. And then in the lower right, we have our iterative. So for example, here, maybe we're developing a new corporate headquarters building, and in their head, they're picturing this beautiful Class A glass and steel office space, large enough for 12,000 employees. And they want it to be a real showcase statement of their corporate identity and so forth. Here, we're going to go through a bunch of design iterations to make sure that we're developing a design that they're going to be happy with at a price that they're going to be happy with, so that at the end of the project, they end up with a new building that they really like at a price they're comfortable with, instead of buyer's remorse, where they end up with a building that they really don't like, it doesn't really fit them, and it costs more than they wanted to spend. So now they have buyer's remorse. Well, that's going to be terrible for our repeat business as an architecture firm. So we don't want that to happen. And so we're going to very carefully take the customer with us through this design journey, through all these design iterations, to make sure we end up at a place they're going to be happy with. So that's the idea of incremental and iterative versus predictive. Any questions so far before we press on? Nope. Okay. Now, when we put these together, the iterative and the incremental, we get Agile. So the clinical definition of Agile is a combination of iterative and incremental, where we're going to do iterations of work and deliver increments of value. Another iteration of work, another increment of value. And a very common interval talked about in Agile is 2 weeks. So we have a 2-week iteration of work and another. Here we had a very small increment of value. So maybe what we built over this 2 weeks, the customer didn't like. That's okay. We only lost 2 weeks. We got feedback and we press on. So the idea is you're getting frequent feedback from the client, and you're delivering value along the way, and you're staying responsive to their changing requirements. And the requirements change for several reasons. First, especially with software development, it's really hard for the client to communicate what he needs until he starts seeing prototypes of the software. He doesn't fully visualize what it wants to look like. And so we need to really develop the software in this kind of way with the client to make sure that he sees what's possible, he gets new ideas, we respond to them, and we travel through this design journey together. And so that's the clinical definition of Agile. And I say clinical because with that comes a whole bunch of other ushy-gushy, soft people skills kind of stuff, which we'll talk about. So this Agile Manifesto was developed in 2001, where a handful of software developers got together to compare notes and talk through what they're doing that works with software development to try to find some common threads that they could identify. And they came with different practices, different frameworks, and they all had strong egos and strong opinions about what works. And so they struggled to find common ground, but these 4 core values is where they felt very comfortable agreeing on some common ground. And so I want to go through these 4 core values briefly here. First, it says we value individuals and their interactions over processes and tools, because it's really the individuals and their interactions that are going to help us get to an awesome product solution, not the frickin' processes and tools. We need the processes and tools, but it's really the individuals and their interactions that are so critical to get to the optimum solution we're trying to get to. Second, we value working software over comprehensive documentation, because it's the working software that has value, not the documentation. Third, we value customer collaboration over contract negotiation, because it's really that customer collaboration that's going to get us to this awesome design solution. Whereas if we try to rely on the contract negotiation to do that for us, it's just not going to work. We need to have a contract, we need negotiations, but that's not how we're going to get to an awesome solution. So we need to recognize the limitations there and respect the importance of that customer collaboration. And then finally, we value responding to change over following a plan. Having a plan is important, but being myopically tied to it is a mistake. And anything we can do that enables us to remain more responsive to change is clearly desirable. If we get locked into a plan, which then becomes not such a great plan, we're kind of stuck. So we want to try to avoid that where we can. And these 4 core values make a ton of sense. And I would argue that we should respect these 4 core values on any project we do to the extent possible. Now, along with these 4 core values, there were also 12 principles that were eventually developed and are also a part of the Agile Manifesto. But really, I think these 4 core values are the much more important piece and what you want to understand for the test. And some of those other 12 principles, I'll touch on the gist of them in following slides. But let me just pause here again and ask if there's any questions up to this point. Nope. Okay. So notice that the talk here is about software, and there's been a lot said over the recent years about how Agile can apply to other types of work besides software development, which in some cases is true. For example, digital marketing campaigns where you might do iterations and do ABC testing and then analyze the results of a cycle and design the next cycle based on those results. You could imagine how an iterative 2-week cadence could work there also. Other types of new product development, especially in the early design phase, these more agile approaches could be beneficial there. But as soon as you start cutting metal and ordering long lead items and paying for production grade tooling and fixtures and so forth, the cost of change goes way up, and you're going to become much less interested in hearing about new changes once you've gotten to that point. So I like to say Agile has its place, but it also needs to be kept in its place. And there's a whole lot of hype these days about Agile being the best thing since sliced bread, and we should be using it everywhere in project management. And that's just silly, dead wrong stupidity, which is happening on a global scale right now. We have this massive global groupthink nonsense going on now, where there's irrational exuberance over Agile, as if it should be applied everywhere all the time, which is just asinine. So we gotta understand its limitations as well. Where does it fit and where does it not fit? And understand that there's a whole lot of management by fad going on, as has always been the case. It's going on now too with Agile. In the past, think of statistical process control, just in time, Lean Six Sigma, et cetera, digital transformation, et cetera. So you gotta keep your common sense engaged as you're thinking about project management. Now, one of the people who are listed here is Ron Jeffries, and he was also actually one of the contributing authors of that Agile Practice Guide that you see wrappered with the PMBOK guide. Martin Fowler here has a blog, and some years ago he wrote about, according to his memory, it was really Jim Highsmith and Dr. Bob Martin who were the chief organizers of this get-together, which led to the Agile Manifesto. Kent Beck is associated with extreme programming, which is one of the Agile frameworks talked about in the Agile Practice Guide. Alistair Coburn, it's pronounced Coburn. He doesn't like to be called Cockburn. He's associated with this crystal family of Agile methodologies, which is also mentioned in that Agile Practice Guide. Ken Schwaber and Jeff Sutherland are very closely associated with Scrum, which is far and away the leading Agile framework. And so all these guys came with different methodologies and different practices they were following. But they were able to come together and agree on these 4 core values here. And then this was like revolutionary. This kind of planted a flag, giving Agile some huge credibility and popularity, which just grew from there massively. And so I want to spend a few minutes talking about why it was received with so much enthusiasm. So before this meeting, people were struggling to manage software projects better. There was so much dysfunction. think it's fair to say that more than half of software development projects would fail massively, just horribly fail. And it was largely because it was really hard to get inside the head of the client and establish the requirements up front. One of the things I was involved in this in the late 80s, early 90s, CASE, computer-aided software engineering. So we had some software tools to help us sketch out how the software would work. And then we'd share that with a client to kind of talk it through with them. And then there was something called JAD, Joint Application Development, where we'd get all the right people in the room and try to talk through what we want the software to do. And no matter how hard we tried, as we try to define the data elements up front and the business rules up front, the client's thinking would change as he started to see prototypes. And so we'd have to do a whole bunch of rework. And if we tried to follow a predictive project management approach, we would end up running late and going over budget just about every single time, because it just wasn't the right approach. And people were floundering around trying to find a better approach. So we see this rapid application development, this dynamic systems development method, object-oriented programming became very important and valuable. And I think it's fair to say that all of these people were most likely following object-oriented programming trends, which took off after I was involved in this with using CASE and JAD in the late 80s, early 90s. The object-oriented programming came somewhat later than that, at least as far as my awareness of it goes. So there was this rough and tumble, messed up world where people weren't running software projects very well at all. And the software developers were really frustrated because they just knew there had to be a better way. And they were burnt out and frustrated because of, it's no fun working on projects that fail over and over again, knowing they could have been successful if they had just been managed differently somehow. So when Agile came along, the software developers were just really enthusiastic. When they tried it and saw how well it worked, it was just amazing. So that explains some of the enthusiasm that has developed since the manifesto was published. And just reviewing further how messed things up were back in the day, back in the late 80s, early 90s, throughout the 90s, people were still using mainframes and COBOL programming, and the compute capacity was very expensive. The software was typically ugly spaghetti code, very unstructured and not professionally done. No matter how hard you tried to tell the software developers to comment their code and use subroutines to give it some structure, they were trying to work fast and meet deadlines, so they tended to take shortcuts and create this ugly spaghetti code that other people would really struggle to understand. So later, if somebody else needs to maintain it, you basically have to reverse engineer it to even understand what the heck is going on. And then you had these clunky punch cards where the code was represented on these punch cards to get run through this mainframe. And then if you're lucky, you get the output 2 hours later. You might actually wait overnight because maybe it got batched up to run in overnight scheduled job batches. And so 2 hours or the next day, you'd get the output in this lovely S-folded computer paper. So it was slow turnaround. So if you're trying to debug software, debug a really complicated algorithm or whatever, every iteration might take you 2 hours to a day. And so it was really slow. Also, the compute capacity was expensive. The storage was expensive. And so, big companies would have their production environment, but then their development environment for testing, their test environment was typically very small compared to the production environment. So it just wasn't representative of the production environment. So no matter how hard you tried to test thoroughly, there was still some remaining risk that when you put into production, unforeseen stuff might happen because your test environment just wasn't representative of your production environment. So when you're making changes to the software, there's risk because maybe something bad's going to happen when you put it into production, which makes everybody risk averse. So they're very reluctant to make changes. So with Agile, you're all about being responsive to change. Well, with this old technology, it was expensive and slow and risky to make changes, which does not encourage an Agile mindset at all. Another problem, you had this huge cultural gap between the software developers and the business end users. They were just on different wavelengths, and they had learned to hate each other because they'd done so many failed projects together. The software developers were frustrated with the end users because the end users would keep changing their minds. They couldn't define their requirements up front. And the end users were frustrated with the software developers because the software developers didn't seem to, be responsive to the client's needs and challenges. And they seemed to be kind of elitist, technical know-it-alls, and they were culturally far apart from each other. And so this cultural gap was a huge dysfunctional dynamic. So you had all these challenges to improving IT responsiveness, the cultural challenges, and things like the JAD and the case tools that they tried just weren't enough. They weren't solving the problem. You had the technical challenges, weak test environment, expensive, slow, risky to implement changes, and management wasn't finding ways to overcome these challenges. They tried different things like outsourcing IT. So now you have lower cost people working in India, and you have more difficult communications challenges trying to coordinate with them. And that didn't go very well either initially until people learned how to work long distances more efficiently. So you also saw end users revolt and launch shadow IT efforts where they said, "Screw our IT department. We're gonna build something ourselves," and then that creates other risks. And so with all this going on, a fresh approach was desperately needed, and the software developers and end users needed to find a way to collaborate better and build business value together much more efficiently, successfully, rapidly, cost effectively, and improve their responsiveness. And Agile turned out to be the perfect solution for that, for much software development. So much so, it's just remarkable. So it, as I say, it has its place, but it needs to be kept in its place. So we have these different flavors of Agile, and the first three are the ones that are especially important for the PMP test, and to some extent for the CAPM test. Now we're starting to see a little bit of Agile touched on in the CAPM, and then a whole bunch in the PMP exam. And in the Agile Practice Guide that comes wrapped with the PMBOK Guide, you'll see all of these mentioned. And it's worthwhile to read through that Agile Practice Guide to have that very surface level understanding of all of these. But these first three are by far the more prominent and important. And so we want to know a little bit more about those, which is what we're going to focus on today. So let me pause here again and ask any questions up to this point. Okay, not hearing anything. Press it on. So first, I want to touch on extreme programming because the really serious agile practitioners I've talked to tell me that it was really his book, Extreme Programming, that is where they first learned about agile concepts, and it just made a huge impact on them. And he was involved with this Chrysler payroll project in the early 1990s, which, like so many big software projects, meandered for years unsuccessfully. And he came in, got involved with it to get it more on track, and really developed or refined his extreme programming practices in that engagement. And so his framework for extreme program really gets into the nuts and bolts more of software development. And so the word extreme is the idea that he's taking best practices to extreme degrees. So one of his best practices was this idea of test-driven development, where he would actually design the tests of what a piece of software needed to do before he even wrote the software. And then he'd write the software, and he'd use the test to check the software to make sure it wasn't having any defects in it. And then this was taken to an extreme where the snippet of code was going to be just minuscule, and a test would be written for that minuscule bit of code, and then that code would be written and tested. So over time, as you develop hundreds and hundreds of snippets of code, you develop hundreds and hundreds of these automated tests. And by the way, this was automated because it would have taken too long to do it manually. So a huge shift towards automated testing was part of the best practices too. And the idea that very small snippets of code were the units being developed and tested through automated testing, which means special tools to do the automated testing, special skills to know how to drive those tools for automated testing. So new skills, new tools being developed to support this direction as well. And through this approach, you would avoid having a lot of defects creep into the software. So you're creating better software that's much less buggy. Another practice was this idea of pair programming, which might seem inefficient, but the idea is you'd actually have two people sitting down together in front of one monitor and one keyboard, and one person would be doing the programming, and the other person would be kind of looking over their shoulder, and they'd be talking it through together. So two heads, two pairs of eyes, talking it through as they do the coding, and then maybe they would switch roles every once in a while, and the primary would become the observer, and the observer would become the primary programmer. And by having these two pairs of eyes, it would help them use better practices, better tricks, more efficiency, more sophisticated programming approaches, fewer dead ends, fewer suboptimal approaches, just better quality. And it surprisingly, it turned out to be a very productive trade-off, at least in many cases. And then another practice or philosophy of his in his extreme programming framework was this idea of code for today and refactor later as necessary. So in other words, there's this tendency to want to establish all the requirements and fully define the architecture completely up front, and that can take a lot of time, and it might still lead to a dead end that you're not going to discover is a dead end until later. So his thinking was, no, let's not do that. Let's not go down that rabbit hole. Let's just press ahead today. Let's code for what we know today, and have faith that we're going to be given the opportunity to refactor later. And by refactor, what we mean is actually go in and revise the code to clean it up, shift the architecture a little bit, because we've realized this slightly different architecture is going to work better. and clean up some stuff we did that wasn't as efficient as it should have been, and if we clean it up, it'll be easier to make additions and revisions in the future. And so you need to have faith that you're going to be given the opportunity to do that refactoring later. The risk is people would say, no, we want you to develop new functionality. We don't want you to clean up the existing functionality. And then that's a problem. So you need to have this trust in the reality that you will be given the opportunity to refactor later, in order to have the courage to code for today, instead of spending a whole bunch of time trying to nail down a finalized architecture and a finalized approach today. Very tricky balancing act, and it really takes judgment, but this was also a breakthrough in thinking that with software development, making this trade-off, it just turned out makes it works really, really well. Ahead of time, just hypothesizing, you might quibble about it. You really had to try it and see it work to believe in it. And so Kent Beck, really deep subject matter expert, software developer / software development manager, had developed these practices and saw how well they worked, and then wrote that book. And this, I think it could almost be argued that this was a very important seed, which led very shortly after to Agile being conceptualized. So within his framework also, there's these 5 core values of communication, simplicity, feedback, courage, and respect. So communication, you need really good communication amongst the development team and with the client. Simplicity, we need to keep our approach as simple as possible. We don't want to go into complexity for the aesthetic beauty of the complexity. That's a bad idea. Keep it simple, stupid, as much as possible. Feedback, getting feedback on your prototypes as you're developing the software. Courage, meaning the courage to press on and code for today, knowing that you'll be able to refactor later. Also courage to have honest, frank discussions about how we're working together as a team within the development team, and how we're communicating and collaborating between the development team and the customer, instead of just telling the customer what he wants to hear and stuff like that, which just isn't going to lead to as efficient of a workflow. And then respect, for the productivity of the team, you need to have respect within the team. You need to have respect between the team and the client. And that cultural gap had really hurt that respect. So that respect and trust needed to be rebuilt over time through successful project engagements. So this is extreme programming. A little bit more about it. They're more on these key practices. So I've mentioned refactoring, which is this cleaning up of the software periodically. And there's this idea of pair programming or mobbing, where, I talked about the pair programming, getting 2 people to sit at one terminal and work together to write the software. Mobbing, you could even have a whole little development team of 7 people crowded around a monitor, staring at it intently, studying it and talking about it, and kind of talking through what's going on. And maybe they're thinking about how it would be refactored and talking about different approaches. Test-driven development. So that's the idea that we're going to write the tests and then code and code to the test and test it to make sure that snippet of code passes the test. And then this idea of continuous integration. where you have your main code base, and you're developing, today we're developing some software modules, some subroutines, some algorithms, whatever. Well, we're going to integrate that into the total main code base at least once a day, and probably multiple times a day. Because as we integrate it, we'll discover any dependencies, interactions that we didn't anticipate with other parts of the main code base. So we're doing this continuous integration to make sure that we're surfacing any problems where something doesn't play well with the other pieces. We don't want that to remain hidden from us, because then we could develop a whole bunch of software which has problems in it, where this is going to surface the problems right away, and then we're going to cross train so that we're at least 2 deep wherever possible. So we don't want to have one database subject matter expert and everybody, the whole team is dependent on that one expert. We'd really prefer to have at least 2, maybe even more people be at least somewhat familiar with the database stuff, so that we're not dependent on one subject matter expert. And then we want to avoid accumulating a whole lot of technical debt. And technical debt is that idea that the software has gotten clunky. It's started to develop some dependencies and some complexity, some inefficiencies that makes it hard to maintain and hard to add to it. And so periodically we need to go in and clean it up and do this refactoring. And it's a judgment call as to how much and when to do that. And I'll come back to that and talk about that a little bit more in a few slides. But this is teeing up extreme programming, which, as I say, is getting into the nuts and bolts of the software development a little bit more. Whereas the next framework, Scrum, is much more about the workflow and the roles of the Scrum practices, as opposed to the software. So it's really not talking about the technical challenges of the software development itself. It's really just an approach and a framework to deal with the ambiguity and to accomplish the iterations to support the discovery of the design direction together as a team with developers and representatives of the customer perspective. And as I say, this is by far the most prominent, important Agile framework out there, and important to know for the test. A certification you may have heard of, the CSM, Certified Scrum Master, is a very well-known certification in the Agile world. So we're going to go through all of these different Scrum practices, the roles and activities and artifacts and rules and so forth. And Scrum also comes with its 5 core values: commitment, focus, openness, respect, and courage. And those, if you'll recall, sound a lot like the ones that came out of extreme programming. And these can be found within a document called the Scrum Guide, which is a nice, concise 13 pages, published and maintained by Ken Schwaber and Jeff Sutherland. The most recent version was published just in November of 2020. And so now we're going to drill into the pieces of the Scrum practices a little bit more. But let me just pause here and ask if there's any questions up to this point. Abel.
Yes, please. I intend to know more about this continuous integration under the continuous integration under TTD. How do they connect?
So picture the team in a room working away. Most of them are in pairs, coding together.
Okay.
Maybe one guy is doing some automated testing by himself because that might only need one person at a time on it. Maybe another individual is working on some database work by himself. The Scrum Master is standing around just kind of watching and maybe coaching some behavior corrections once in a while, shooing away some manager who tried to pop in and say, no, you don't come into this room. Mm-mm. Protecting the team so the team stays productive. And then the continuous integration, well, people have been developing software all day, and there might be some dependencies in that software which we're not going to find until we've integrated it into the main line, the main code base. And so we need to take those snippets of code and integrate them into the overall code base at least once a day, preferably multiple times a day, to surface those dependencies that we're not going to find any other way. And we're doing that to avoid accumulating technical debt because those dependencies, when we haven't discovered them, are stickiness that's going to mess us up, and we don't want that to accumulate. We'll create more of that stickiness unless we learn about this stuff. So that's an explanation of why the continuous integration needs to happen. As far as what it looks like, it's picture a big complicated computer program, and now you've just developed a new subroutine which is complete and tested, and now you're going to plug it into that larger program, and then within that larger program you may have some automated testing that will test the interactions between all the different objects or subroutines or pieces within that whole big program. So from a physical standpoint, that's a hand-wavy attempt to describe what it might look like. Does that help at all, Abel?
Yes, please.
Okay.
I can get it.
All right. So these diagrams here I'm using with permission, and I just need to show this slide to have that permission. So I got a license to use his diagrams as long as I show this page from his book. So this is a really, really good book on Scrum. It's called Essential Scrum. The author's name is Kenneth S. Rubin, R-U-B-I-E-N, I'm not sure.
I picked up this book when I went through your class last time. I haven't admittedly looked through it, but I picked it up when you mentioned it last time.
Yeah, it's a really good book. And he had a graphic artist design all these graphics specifically for the book. And so with his permission, I'm using them in this presentation here. So all of the requirements are held within a product backlog, and the individual items are sometimes called product backlog items, abbreviated PBI. And the higher priority ones will be up at the top. And they're refined and made smaller and more clear as they approach the top. So as we do sprints, we'll pick off 3 to 5 or whatever user stories from the top that are ready for the next sprint. And then others will get reprioritized and refined and made smaller and more clear as they approach the top. So they're becoming more and more sprint ready as they approach the top. And we have this verb grooming where we shuffle around the product backlog. We might insert an item. So maybe somebody came up with a new idea. It's a change request. And instead of having a change control review board tearing their hair out, debating whether to approve it or not, we just say, where does it fit in the priority? Let's put it into the product backlog. Let's prioritize it. And we'll get to it when it rises to the top. So we're putting less checks and balances into change requests. We're staying, very receptive. Change requests become new user stories or new product backlog items that get clarified and shuffled into the product backlog where appropriate. And larger user stories might be refined, broken down into smaller user stories so we can understand them better as they work their way up and get reprioritized. And some might get deleted. We might say, we don't need that. Let's just delete that. So there's the grooming of the product backlog as we shuffle user stories into different positions up towards the top for higher prioritization, further down if we're going to deprioritize them for a while. And so up towards the top, we're trying to get to these smaller sprint-ready product backlog items, and they're often called user stories. And the structure of the user story has a certain format where we say, as a such and such type of user, I want to perform such and such a function for such and such a purpose. So the whole idea of a story is to give context to the requirement so that the developer understands more clearly what it's supposed to do, so he or she knows how to write the software to provide that functionality. And then larger product backlog items are sometimes called epics. So the epic is a big, massive thing which will be decomposed eventually into smaller pieces. So we have these different roles: the product owner, the Scrum Master, and the development team. So the product owner is responsible for providing the voice of the customer. It's analogous to a very senior level business analyst in the Agile world. And the Scrum Master is kind of like a project coordinator, you'd say. It's somebody who's going to facilitate the whole interacting of all these different roles, protect the team from management meddling, point out behaviors that could be improved, and basically help the whole team interact and be as productive as possible. So very much a servant leader kind of position. And then the development team are the people with the deep subject matter expertise to actually write the software. So here you have people who are, as much as possible, cross-trained, multidisciplinary subject matter experts. So they might be really strong at coding in several different languages, but they also know a little bit about database design and a little bit about automated testing and so forth. So then the work is organized into these sprints, and the sprint is a time-boxed design iteration, and the sprints follow one after another, and there's a bunch of activities within each sprint. A very common interval talked about is 2 weeks, but it depends on the nature of work. Some work it might be possible to use a 1 week sprint. Some work might be more complex. It might take 4 weeks. So it really depends on the nature of the work. Within each sprint cycle, we have a bunch of different activities. And I'm not able to watch the chat while I'm talking. So if you have a question, please feel free to interrupt me to ask. So within each sprint cycle, there's going to be some product backlog grooming, shuffling user stories around, getting enough user stories sprint ready for the next sprint planning cycle. And so then at the beginning of the sprint, we do the sprint planning where we figure out how many user stories we can reliably complete in the next sprint. And we want to try to take in only that many user stories. And then we form our sprint backlog of the user stories that we're going to complete in this sprint, and then those might be broken down into tasks pretty much by the development team for their own purposes. And then that sprint backlog is going to be what's worked on during the sprint cycle. Say it's 2 weeks, and so we're doing that work, and the goal is at the output, we're going to get some potentially shippable product increment. So we need to define up front what it is we're hoping to get out of the sprint. And then what we're going to do is we're going to have a sprint review where we review that piece of work with the client, with the product owner, and with other representatives of the client. And so we'll do a presentation, we'll get their feedback, and we're doing this inspect and adapt of that potentially shippable increment. So that's the sprint review. And right after that, we'll have a sprint retrospective where the core team will get together and talk about, first, how did that sprint review go? And second, how did this whole sprint cycle go? And is there anything about the way we're working that we should change? What changes could we make that would make us an even more effective team going forward? So we're inspecting and adapting what we're building and the way we're working. And once we complete all of these steps, we're ready to do the next sprint cycle. And if each sprint cycle is 2 weeks, all of these pieces happen within that 2 weeks. And so the sprint planning, we're not going to spend days and days. Everything is lightweight. We're going to spend no more than a half a day at the very most doing this, because we want to preserve as much time as possible for actually doing the work. And at the end of it, we're going to have a meeting to review what we built. That might be just 2 to 4 hours. And then a sprint retrospective, that might be just 30 to 60 minutes. So as much time as possible is preserved for actually doing the productive work. And at the beginning of each day, we're going to have this daily scrum where the core team stands around in a circle and goes through what they did yesterday, what they intend to do today, and any impediments they foresee. So it's a quick syncing up at the beginning of each day to help them communicate and identify any problems and work them out. And going a little bit deeper, it's an accountability check-in, because really what you're saying is, what did I commit to doing yesterday, and did I live up to that commitment? And if not, then we've got a conversation there. And then what am I committing to do today, and what impediments do I see? Well, let's talk about those proactively so we don't have to have this conversation again tomorrow. If you have some impediments, let's try to solve those. One of the problems you have with teams is some team members are high performing and some aren't. Well, with this daily scrum, one of the things you're going to do is you're going to surface the weak performers, because every single day it's like he or she didn't live up to his commitments. The next day, pretty soon, the person himself hears himself talking and realizes, God damn it, I'm not living up to the expectations of everybody else on this team. I need some help. I need to up my game somehow. And so it kind of creates an environment where everybody starts holding themselves accountable too, and really tries to get that team to become an ever more high performing team. And so just create some of the accountability to make that a reality. And this is kind of the nature of Scrum. It's a lot of it comes down to a framework, a way of working that when everybody plays ball and is on the same page can be just really, really effective for really good collaboration where you need to navigate ambiguity. So each sprint starts off with the sprint planning, and a sprint goal will be defined. What's that product backlog increment that we hope to get out of it? What user stories are selected as the input? And as we select them, we're looking for what's highest priority and achievable within the sprint. And by highest priority, ideally, the business is going to be able to put it into production and get business value out of it right away. That's best case. That doesn't always happen, but that would be best case. If not that, at the very least, it would be resolving some really important design question, burning down some risk or uncertainty that we need to resolve, that kind of thing. And then we need to be really clear on what our definition of done is. So if the expectation is we're going to produce something that's going to be put into production, then that means we're going to do some much more thorough integration testing and so forth. If our definition of done is that we're going to get a low fidelity wireframe for customer feedback on design direction, well, that's a very different definition of done. And so we want to be clear on what that expectation is. And then the sprint backlog is the collection of user stories we're going to create during the sprint, and so that's formed up. Here's the 5 user stories we're going to complete during this sprint, and that's going to be done largely with input from the product owner, who's providing the voice of the customer and will authoritatively speak to what's most valuable to the customer, and will authoritatively clarify any requirements that are unclear to the developers. There'll also be input from the development team, because they're going to be in a better position to understand how difficult these user stories are and how many of them they can realistically complete during the sprint. And then the Scrum Master will be involved to make sure that the dynamics of the conversation are flowing appropriately. So he's kind of a referee. It's like the referee of a soccer game, making sure everybody's following the rules, blowing the whistle on penalties and so forth, making sure people aren't crashing into each other, banging their heads against each other and killing each other. And so then in the process of creating the sprint backlog, you'll also create a high-level sprint execution plan, but high level, not days and days of planning. This whole process will be half a day at the very most. So 4 to 6 hours max time spent per sprint. So that's the sprint planning. And now circling back to this technical debt, there's 3 different categories. There's naive, unavoidable, and strategic. So naive technical debt is we naively went off in a certain direction as we created the code, and now we realize that that was a poor choice of direction, and there's a better way to do that search or sort or display or database retrieve command or whatever. And so now we know better, and so we're going to fix it. Unavoidable, the idea that we just didn't know enough. We went in a certain direction, and now we understand different requirements, and so we realized that that was a false direction, and so we need to adjust based on that newly gained understanding. And finally, strategic. So we might make a strategic decision to crank out some code to provide some functionality to meet a certain deadline. Perhaps we want to get something into a release. It's really important for the business to get it into the release. And so we we indulge in some shitty coding practices and we crank out something that works, but we know it's shit. We know it's not the way it should be done. And we bravely crank it out because we know we're going to be given the opportunity to refactor it later. And we consciously make that trade-off to incur that technical debt now. And we know that we're going to fix it, clean it up later on. And so now we need to manage this accrual of technical debt, make it visible, and service it in a economically sensible way at the appropriate times. So maybe we can live with it for 3 weeks before we refactor it, and then it becomes such a serious problem we really got to spend some time refactoring. So maybe we get to this point where on a certain sprint, we need to spend 3 days of that sprint refactoring. And we're probably just going to sneak that in instead of telling the client, hey, we're stealing 3 days from this sprint to refactor. We just tell the product owner up front, from time to time, we're going to have to refactor. And so from time to time, our sprints might appear a little bit less productive to you. We doubt that you're even going to notice, but if you do, understand that from time to time, we have to do some refactoring. And so we may spend several days out of a sprint cleaning up some code. That's just the nature of the work. And so we kind of give ourselves blanket permission up front to do that when we see the need to do it. And it's us as the software development team who is autonomous left to make the decisions on when to do how much of that refactoring. And this word debt is interesting. Just like financial debt, if you let this technical debt accumulate, eventually it'll just crush you and put you out of business. Eventually you'll come to a screeching halt. You've accumulated so much technical debt that your code is brittle, and anytime you try to make a change or an addition, it breaks 15 other things. And you urgently need to refactor before you do any other work, because you've reached this point where it's just, you gotta refactor. And you probably don't want to get to that extreme point. You want to proactively refactor before you get to such a brittle state. But that's just to dramatize that it's like financial debt. If you're a department store that accumulates so much debt that your banks start calling your loans and put you out of business. Now you're Chapter 11 because you accumulated too much financial debt. Well, too much technical debt could put you out of business too. So you really need to avoid getting too highly leveraged with that technical debt. Okay, so coming back to the Scrum practices, the product owner is an extremely central figure. He or she is interacting with all the internal stakeholders to keep himself aware and able to represent the voice of the customer as authoritatively as possible. Internal stakeholders interfacing with customers as well, or end users. He's interfacing with the development team to clarify the requirements within the user stories to help the development team understand more clearly what the heck it is they're trying to create. And he's communicating with the Scrum Master to help keep everything flowing smoothly and to make sure that the work dynamics are as cordial and productive as possible. So the product owner is not a lightweight. A lot of times you'll see a business analyst as somebody who's a little bit of a lightweight. They're just kind of running around communicating requirements from the end user back to the development team. But then you see business analysts who are very senior, who have deep understanding of how the business works, and they understand the customer perspective in a much more deep and strategic way. And that's really the level we need out of this product owner. It's not a lightweight junior business analyst. It's an extremely senior level, knowledgeable, strategic thinking business analyst, product owner. So business analyst is a little bit of a stretch. Product owner in big companies is typically somebody who's responsible for a certain product across everything, across its whole life, from design and implementation to sales, communicating with marketing, communicating with inventory, and so forth, and creating sales collateral for the salespeople and so forth. And so that's the product owner here too, a really knowledgeable person and central to the whole process. So this is a slide about the sprint execution, where the development team is going to do the work. The Scrum Master is going to facilitate the interactions. The product owner is going to be available to answer questions about the user stories and other requirements as they come up, to provide context and so forth where needed. The Scrum Master is going to ensure that everything flows smoothly. And for example, he's going to make sure the team is left alone to manage themselves, that they're not interrupted, that they're not asked for status updates in the middle of their sprint, that they're not told how to do their work, that they're not assigned additional work for the sprint in the middle of the sprint, and they're not pressured into staying late and working long hours and so forth. One of those 12 principles, one of those subtle things that comes along with Agile is this idea of we're going to work at a sustainable pace. We're not going to burn people out and ask them to work 16 hours a day, 6 days a week, because we have a tight deadline and we mismanaged them, so we got 3 months behind, and now we're going to work them into the ground, because nobody likes to work that way, and it's not even efficient. You burn out, you lose productivity, and so we're just not going to go there. And so one of the underlying principles of Agile is we're going to work at a sustainable pace. We're going to be professional. We're going to work hard, but whatever a sustainable pace is, maybe it's 8, 10, 12 hours a day, maybe it's 5 days a week, but we're an autonomous team. If we all agree that we're going to get here at 9 a.m. and leave at 7 p.m. or whatever, it's our call. Nobody's going to tell us company policy says you have to punch in by 8 a.m. This is going to be a different environment than that. And even if the rest of that company is that way, that's not the way this team is going to roll. So you can start to see how you could see some tension between this team and the rest of the organization. If the rest of the organization is a very strict command and control, punch in by 8 a.m. and this team is a bunch of cowboys who come in at 10 a.m. and work until 9 p.m. because they feel like it, that's just the way they're going to roll. And you better get used to it. And so you can just imagine how you start to get some clashes. You get some senior managers saying, I don't like what I'm seeing. I think we need to tighten up on these guys. And then that's gonna kill the magic. And so the Scrum Master needs to protect the team with fierce determination. But already you can start to see how you can get tension here. If the organization isn't ready to respect this type of engagement, it's simply not going to work. And so a lot of companies struggle to adopt Agile successfully for these kinds of reasons, which is why you see these Agile coaches running around trying to help companies adopt Agile more successfully. So the daily stand-up I mentioned, but let me just pause here. Any questions up to this point? Nope. Okay. Pressing on. In the daily stand-up, I talked this through. We're going to talk about what did I accomplish since the last time we met? What do I plan to complete today? And what impediments do I anticipate? But going a little bit deeper, it's really how well did each team member keep their commitments from yesterday? What commitments is each team member making today? And how can the team members coordinate and collaborate today to be more successful in meeting their commitments? So it's really an accountability check-in and a coordination opportunity. And it's brief, it's 15 minutes max, and then they're going to get to work. And they stand up because they don't want to get too comfortable. You sit down, you get comfortable, you talk for an hour and a half. You stand up, keep it to 15 minutes. If you want to get really serious, stand up and stand on one foot. You want to get really, really serious? Put your hand in a bucket of ice water and only talk while your hand is in the ice water to make sure you don't run too long. Whatever it takes to keep it productive and moving briskly. So the sprint review is where we take the output of our sprint and inspect it. So what are the inputs? We had that sprint goal of a product increment, a potentially shippable product increment that we want to get out of it. We had the sprint goal, the sprint backlog, and that potentially shippable product increment. At the end of the sprint, we're going to inspect that increment with the client, the product owner, and other representations of the customer. So we'll present an overview, we'll do a demonstration, we'll discuss it, and we'll adapt. And then the results of all that, the output of that sprint review, will groom our product backlog, shuffle things around based on what we've learned, and we'll perhaps update release plans. So not every sprint, but perhaps every 12 sprints or whatever, we might have increments, release plans. So this is where we're going to actually put stuff into production. And so we might adjust those release plans periodically as a result of what we learn in these sprint reviews. So that's the sprint review. And then the sprint retrospective, this is where the full core team gets together and reviews what's working well, what could be improved in future sprints. The Scrum Master will typically facilitate this. The product owner will be included, and the development team, but any others only by invitation, because you really want the core team to be able to speak freely and speak their mind. And so if there's other managers here, that might inhibit the free flow of communications. So that might not be desirable. But by invitation, it might be okay. If there's some director of marketing who is interested in this project and wants to observe, maybe you're happy to have that visibility. And so you say, sure, we'd love to have you. But understand you're an observer. And so I need to ask you to please be quiet. If you have questions, ask me offline later on. You're here only to observe. So in the sprint retrospective, you're going to look at how did that last sprint review go, and how did our work go throughout the sprint, and what could we improve? And then there's this idea of these release plans, where maybe it's every 12 sprints or whatever, we have releases planned at a certain cadence of once a quarter, perhaps. Maybe our organization can only absorb change at a certain rate, like once a quarter. Or maybe we're working for a client and the client can only absorb change once a quarter. So we have releases scheduled for once a quarter, perhaps. And so the inputs to this release planning, we've got the product vision, the product backlog, a product roadmap, and velocity, and understanding of how much work we're able to complete per sprint, which we develop that understanding over time as we work through the sprints. And then in the release planning, we think about the scope of what is in our next planned release, the date of that release, and the budget or the cost that will be incurred to get there. And we review constraints that we anticipate. We review MRFs, minimum required features of the release. And we do some backlog grooming and some sprint mapping as all part of that release planning. And then the output of that release planning, we have our refined release plan, a range of features at some fixed costs, or perhaps a range of sprints and a range of costs to get there. And again, the minimum required features that we expect to see, and a sprint map that we anticipate will get us to that release. So release planning is an important part of the puzzle for Scrum. And it's facilitated by getting an understanding of this velocity. And that comes from doing some estimating of our sizing of our user stories, which I'll get to in just a few slides. But first here, we're showing again that the product owner is a very central piece of the work. He's involved through all of these different steps of the sprint. And he's even involved before we started work on the sprint. Here's the first sprint here. And that product owner would be involved in earlier product visioning, portfolio planning, product planning, release planning. So he's involved in a whole lot of earlier, like strategic level stuff before we even get to work on the very first sprint. So now we come to this sizing. And this is how you develop an understanding of your velocity, which is going to support you as you're doing that release planning. So if you're trying to do release planning, this is critical. And the way it's done is with these poker cards. It's really sort of not intuitive, and it's kind of surprising, but it's been found to work really well. So this is really, I think, the preferred approach. So each user story is going to be estimated. And we're using this relative sizing. It is a very qualitative kind of estimating. And it's going to be done rapidly in a just-in-time fashion with limited information, which is consistent with the whole approach of Agile. We're not going to spend a bunch of time trying to understand everything about our requirements. We're going to press ahead with just a very limited understanding of our requirements, and the requirements are going to get clarified as we go. The estimates will be done by the entire development team as a group. The product owner and the Scrum Master will be present, but they're not going to provide estimates. The product owner will be there to answer questions and clarify user stories, clarify requirements, give context where required. The Scrum Master will be there to observe the process and correct behaviors where necessary. But the development team, these are the people who have to do the work, and they're the people who are going to estimate how big each user story is. And they're going to do that with this planning poker approach, where each developer on the team has a deck of poker cards. And they're numbered with this modified Fibonacci series. So this Fibonacci series we have, 1 + 2 is 3, 2 + 3 is 5, 3 + 5 is 8, 5 + 8 is 13. And then from there we simplify. We just go with some nice round numbers, 20, 40, 100. Infinite, that's basically saying this user story is too big to estimate. It really needs to be broken down. It doesn't make sense to try to even estimate this. Question mark is, shucks, I don't know, I need more information. A half is, this is tiny, tiny. Pie means I'm tired. I want to take a break. I want to eat some pie. And the dynamic is, for each user story, the team looks at it, maybe they discuss it, maybe they ask some questions of the product owner, and then they each pick a card out of the deck and place it face down. So everybody places their bet. After everybody's placed their bet, they turn them over at the same time, and we see, okay, everybody voted 5, but one guy voted 20. Wow, that's a big difference. Let's talk about it. Let's talk it through. Maybe once it's talked about, the guy who voted 20 realizes he misunderstood, and he agrees with the estimate of 5. And so now we've reached agreement on 5, and we can move on to the next user story. So it's a way to very quickly hopefully quickly, get consensus on each user story. So if you got a spread, then you talk about it, then you vote again, and maybe you converged on 13 then. If you didn't converge, maybe you have to talk to some more and clarify it to understand it before you estimate it. But as quickly as possible, you try to get to consensus and then press on to the next user story. And we're not looking for ultimate precision. We're just trying to size these user stories relative to each other. And with this range of sizing, the intent is that the 8 is just different enough from the 5, the 5 is just different enough from the 3, that we can readily agree that, yeah, this is definitely a 5. It's a lot more than the 3. So we start to build a feel as a team for the sizing of the different user stories. And then as we complete user stories that were sized, a 3 and a 13 and a 20, whatever, we realize we completed, for example, 22 story points this sprint. We completed 17 points this next sprint. We completed 27 points the sprint after that. We start to build up data on how many story points we're completing per sprint. They're very rough qualitative estimates, but over time they start to take on a little bit of meaning, and they become good enough to do some very rough approximations to help us ballpark when the next release might be ready. And to try to get any more precise would be being smart beyond our intelligence. We don't know enough to be any more precise. This is the best we could possibly hope for. So let's not pretend we're capable of doing more. And so this has been found to work really well for estimating software user stories. And again, the purpose of it is to build up that historical understanding of our velocity to help us with release planning. Any questions on that or anything up to this point?
Real quickly, the different point scale there, they aren't picking at random. They're just picking the number that they think that'll take as far as like how long it'll take to finish the
yes
sprint?
Yes,
Okay.
definitely. Yeah, if I indicated random, definitely not. No, they're picking. One guy might feel this is an 8, one guy might feel this is a 20, and the difference is because they understood the user story differently, and now they need to get some clarification from the product owner before they're going to be able to converge. Yep.
Perfect.
All right. So as I was saying, this understanding of velocity helps us do release planning. If we are averaging 15 points per sprint and the next release is estimated to be 150 points, divided by 10 sprints, so 15 points into the 150 tells it it's going to take us 10 sprints, and each sprint is 2 weeks, so it's going to take us 20 weeks. All of a sudden we have a rough estimate as to when that release is going to be ready. It's very crude and approximate, but it's a whole lot better than nothing. And it's all we would possibly be able to do. It's as scientific as we can possibly be under the circumstances. So there's something called a burn down chart, which, here we're showing 10 days. So this could be a 2-week sprint, 5 business days per sprint. And so we started with the sprint with 36, 37 story points. And over time, we see plan, a straight line, and actuals, how many story points we actually completed per day. And it turns out that there were 7 story points we didn't complete at the end. So maybe one user story didn't get done, but the others did get done. And that's how that sprint turned out. We want to try to complete all the user stories, but sometimes it doesn't work out. So this is what a burn down chart looks like. And the burn up chart is just going the other direction, showing the work completed as we go. And you might see a test question about burn down charts or burn up charts. So they're showing the work completed either during a sprint or throughout the whole Scrum engagement up until now. You could do a burn up chart across all the different sprints just as well. So pros and cons of Scrum. Pros, you're going to allow yourself to stay responsive to change and remain closely aligned with your customers' wishes and expectations, even as those might evolve over time. And it's been found to work really well with many software development projects where change is typically pretty easy to accommodate. You can delete code and write new code pretty easily. Cons, it's not suitable for all projects. For example, projects with expensive long lead items that you need to purchase, once you've placed those purchase orders, the cost of change goes way, way up, and you're going to be much less interested in hearing about change requests. Other considerations, it really requires a leap of faith from the sponsor to authorize the work, because senior management today is used to having the scope, schedule, and cost defined up front before they even authorize a go-ahead. And here, the whole reason why we're talking about Agile is it's just not realistic. There is simply no way that we can establish the scope, schedule, and cost up front. And so we need to find another way to get the customer or the manager comfortable enough to authorize us to proceed with the work. And also, it really requires close customer engagement. If the customer is too busy to work with us, this just isn't going to work. So the question might come up, why do this estimating? Well, if you have to schedule releases, it's critical. But in some cases, you really don't need to estimate releases. And so then doing this estimating might actually be a waste of effort. So if there's no expectation or need for forecast, you're just going to deliver as you're ready. That's one scenario where you wouldn't need to do this estimating. Maybe you have extremely mature DevOps where you can do continuous delivery. That's very rare, but if you were in such an environment, then you wouldn't need to estimate. You just build and deliver. There's going to be some work that's just maintenance, break fix, service tickets type stuff where you prioritize and you do the work, but there's really no need to estimate. Another scenario is if your sprints are always often being interrupted with urgent new requirements, that might be an indication that Scrum just isn't the right approach, and you should find a different approach. And in all of these situations, Kanban might be a better approach. And so this is my segue into Kanban as a third framework to talk about in Agile. So we started off with extreme programming, and then we did a fairly deep dive into Scrum, and now we want to talk a little bit about Kanban. So Kanban has been around for ages. It goes back to the Toyota production system in the late 1940s. It was super valuable for kicking off the thinking about lean manufacturing and just-in-time inventorying and controlling work in progress limits. And so the way the Kanban board works is it's creating a demand pull kind of workflow, where we read this from left to right. On the right is final delivered work, and on the left is our input of new work. And in between, we have these columns, which are different stages of the work. So in this particular example, for software development, we have a pool of ideas as input. Here, the ideas are being refined, and then some subset of those requirements or epics are being selected here, and then they're being decomposed into user stories here, made sprint ready, and then they're being developed further. So they're going into a sprint here. This would be during sprint execution, or actually here they're just being refined further to be ready. Now here they're sprint ready. Here they're going into sprint execution in progress. And here within the sprint, they're done, but we're still within the sprint. And then at the end of the sprint, we have acceptance. So here they're in the process of being reviewed with the client, the product owner. Here they've been approved and accepted by the product owner. Now they're going through the deployment. And in deployment, there will be certain steps that happen to mitigate risks, and then finally they're delivered. And the idea is that we'll have work in progress limits at each stage. And that's really important because it surfaces problems. If for example, here in acceptance, for whatever reason, we're constantly running into problems and we have a bunch of stuff in progress, we might be tempted to put more work in there because we want to keep people busy, and so we keep pumping work in here to try to get enough into the ready state for the people who do that step. Whereas if we realize, okay, we have problems here, if we keep the work in progress limited to just 8 story points here, and then we come to a screeching halt, that's surfacing a problem. Now we should drill down and figure out what's going wrong, what's causing us to come to a screeching halt. Let's understand that problem, and let's attack it. Let's put a bunch of resources on it and work through and fix it. So it's prompting us to do continuous process improvement, and it's prompting us to surface the problems and then put resources on them to fix them. And if we've come to a screeching halt here, all the flow through here is going to tend to come to a screeching halt too, because the work here can't flow on, new work can't flow in. You have work in progress limits that start to create stoppages all throughout upstream of this problem. So now the resources that are idle here can all be directed to looking at the problem here, figuring out together a way to solve it. And if you hadn't reduced your work in progress, you'd never surface this problem and create the available resources to really focus on it. So you'd be disguising problems and working around them constantly. Whereas with Kanban, you surface the problems, you focus on them and fix them, and in the long run, you're going to get a better, well-oiled machine, a beautiful ticking Swiss watch that is far more efficient because the Kanban system forced you to clean up the problems that were there. So it's a really interesting approach. And even though it was found to work really well in manufacturing by Toyota, it turns out that it works really well for other types of work too. People work, paperwork, process flow within offices, handling insurance claims, handling new sales proposals, handling break-fix service tickets, many different things can be dealt with these Kanban boards. And then these cumulative flow diagrams are associated with Kanban. So we have work in the queue waiting to start. We have work that's gotten started. We have completed work here. We have work that's underway here. So there's in the queue, light gray, darker gray is analysis phase, and darker gray is development phase, and the darker gray is test phase, and then finally deployed. So we have these different timing. So from the very beginning to the very completion, that's our lead time. Our cycle time is from when we actually start work till it's completed. The total volume in this direction is all of our remaining work. This here's our work in the queue. And the shapes of these cumulative flow diagrams can help you alert you to problems. If you see stuff piling up, it might be because something else is causing a problem somewhere else. So the patterns of these bands can help alert you to problems that need to be cleaned up. And over time, if your cycle time is shrinking, that from when and your lead time too, from when work first enters the queue till it's completed, as that shrinks and as your quality improves, you're demonstrating that this Kanban workflow is improving your processes. And so Kanban is an extremely valuable tool for continuous process improvement. And some familiarity with these different terms, response time from the work first enters the queue till you start working on it, lead time from when it first enters the queue till it's completed, and cycle time from when you first start working on it until it's completed. Understanding those terms might be important for the test. And just understanding that a cumulative flow diagram looks kind of like this and it relates to Kanban could be important for the test too. So it's all about limiting the work in progress to surface the problems. And over time, this will enable you to reduce your cycle times. Any problems or bottlenecks will become very visible. This will create slack elsewhere, which creates the capacity to do the process improvement. So as I was saying, it worked well for Toyota in production, and it works very well for knowledge workers too. And you can even use it in combination with Scrum. So within each Scrum sprint, that task order or sprint backlog might run through a Kanban board that the team uses during the 2-week sprint. So it's going to help you reduce cycle times, increase throughput, improve quality, and all of this will lead to increased customer trust. And this can really help improve overall company culture and employee morale. And there's this Japanese word Kaizen, which apparently means something along the lines of continuous improvement. And so it can help lead to that Kaizen culture of really actually not just lip service, but actually engaging in continuous improvement efforts at the company. So it can be a valuable part of a process improvement initiative to help visualize the workflow, and you're going to make your process policies much more explicit, meaning when stuff is allowed to move from one column to another within the workflow. And you can adjust those process policies as appropriate. And there's a book talking about all of this by a guy named David Anderson. It's called Kanban, Successful Evolutionary Change for Your Technology Business, published in 2010. Very, very good book on Kanban. And he does an excellent job of not only describing how it works, but talking about how it helps strategically within an organization. So he does a great job of talking about the business perspective also. And so he has these 6 steps for a recipe for success in process improvement, where first you're going to use the Kanban boards and focus on quality, reduce your work in progress, deliver often, balance demand against throughput, and I'll come back to that, and prioritize the work and attack sources of variability. So balance the demand against throughput. If you're letting a whole bunch of stuff into the queue, and then you have to spend a whole bunch of time prioritizing it, and the queue is getting bigger and bigger, you're spending a ton of time prioritizing, you could end up developing a dynamic where you're just spending way too much time reprioritizing your backlog all the time. And so you might change that policy to say, hey, God damn it, I'm only going to allow so much into the queue. I know that my throughput coming out the other end is only 5 user stories per week. So I'm only going to allow in 5 user stories per week. And so you throttle the input. You say, this is how much I'm able to produce. Until you give me more resources and I can produce more, I'm only going to allow in 5 user stories of input. So that's what's meant by balancing your input with your output or throughput. And then attacking sources of variability, that comes over to quality. And in the quality knowledge area, we talked about the idea that some variation is common cause and some is special cause. And so the common cause variability we fix through painstaking process improvement, but the special cause variability, we need to identify it as such. We need to find the root cause and attack that first and resolve that. So both types of variability, common cause and special cause, we need to work towards reducing it. And the special cause comes first. And then that idea of improving the culture of the company. In his book, he tells a story about how he used it in a couple of different projects and how it created a dynamic that led to an improvement in the whole company's culture, where the inputs, he said, okay, this is my throughput is such and such, so I can only allow this much into my input. And all these different business units that were trying to give him input, he'd say, you guys work it out amongst yourselves. You guys meet amongst yourselves and figure out, I'm going to publish, I have this much capacity once a week. And you guys prioritize amongst yourselves which new requirements you want to submit. And so now the stakes were high, and you had VP level people meeting from different business units or different departments, at least, talking through their different requirements and negotiating which ones were going to be submitted as input to this Kanban board. And so now you had these different functional managers talking together. And initially they were bargaining, horse trading, and then they started voting. And eventually they settled into some true collaboration where they took a broad organizational perspective to think about what really is most important to the company as a whole. And sometimes it wasn't their pet projects. And then the rest of the company saw these people meeting and collaborating better. And so that modeled behavior. So the whole company developed a culture of collaborating better and looking out for the broad organizational perspective. It's a huge improvement in corporate culture that was triggered by a change in this Kanban board policy. So I thought that whole line of thought was really interesting. And that's talked about in detail in this book by Dave Anderson. So I highly recommend that book. And this is relevant not just in software development, but I know a guy who's responsible for maintaining great big heavy earth moving machinery, and he's pulled in 15 different directions every day. And one of the things he has to do is write proposals for a guy who's doing he's an outside sales guy. And so he's got a bunch of different demands on his time, and he was struggling with that competition for his time. And so it occurred to me that this Kanban board approach could be just a mechanism to deal with that, where that outside sales guy and everybody else would be told, here's my throughput, here's my capacity, and you 3 different people need to talk amongst yourselves and tell me once a week the requirements you want to submit for me to handle. So I really think that this line of thought by David Anderson is really interesting for many different areas, including IT desktop support, where you have break fix and other service calls. I've been in several companies where that was done horribly, and I think this Kanban board approach could improve it dramatically. So kind of wrapping up, extreme programming dealt with the nuts and bolts of software development, talking about pair programming, test-driven development, continuous integration, refactoring. Scrum gets into a cadence of work that's really good for the design iterations and helps you plan release dates, which is going to be appropriate for really coherent projects. But Kanban can be more broadly applicable to other types of work where there's a distinct workflow, but it might be service tickets or other maintenance work rather than really discrete projects. So different types of work will benefit from different approaches, and so the word agile is not very specific at the end of the day, and I think people would benefit from being more clear about their terminology. Just blanket statements that agile is the best thing since sliced bread is grotesquely oversimplified. Now, you'll also hear the word hybrid, and a hybrid is not a blend of these different frameworks, like mixing Kanban and Scrum, for example. That's not a hybrid. What the PMBOK guide means by hybrid is a blend of predictive and adaptive. So you might have a certain phase of the project early on, which wants to be more adaptive, and then later on, the cost of change might go up and you might need to be more predictive. And so that would be an example of hybrid, where certain parts of the project want to be adaptive and other parts want to be predictive. And so you'll see a lot of test questions on the PMP exam drilling into that question of, hey, what part of this project wants to be adaptive and what part wants to be predictive? And in general, this perspective of, hey, can the requirements be defined up front? Then predictive is appropriate. If that's not realistic, then you're going to need a more adaptive approach. And so the Statesy matrix can be a way of, a lens, if you will, to examine that question. And there's this thing called anti-patterns. So a design pattern is something that's been found to work well. An anti-pattern is something that might look like a solution, but it's a bad solution. So it's bad practices. So for example, you can see these cultural readiness issues where a big company with a command and control theory X style of management struggles to adopt Agile successfully. And when they try, the Agile just feels fake. In these same organizations, the sense of psychological safety might be completely lacking. And that's something which has been found to be very important. Simply meaning that people need to feel comfortable speaking truth to power. And if you don't have the sense of trust to be able to do that, everything is screwed. You're going to get groupthink. You're going to all march down to the cafeteria that nobody wants to eat at because nobody spoke up to say, no, let's not go eat there again, for Christ's sake. So sometimes senior management tries to play along, but their habits are ingrained, so they just don't play well with Agile. You often see Agile theater where people go through the motions of trying to follow Scrum practices, but they don't really understand the practices or how to do them properly, or there's other pressures within the organization that distort everything. So they're going through the motions, but it's just not real, and it's not going to work because they're just not really doing it right. And so the result of that, I've heard it called an Agile burrito. Sometimes you'll see these soft Agile practices on the inside, but a stiff wrapper of predictive practices around the outside. And then somebody else called that, it sounds more like taco salad to me. So it's not really going to work. And then the anti-patterns are things that are the opposite of good design practices. They're things that were intended to be solutions, but they're really bad solutions. So for example, micromanagement, analysis paralysis, heavy overtime, crappy spaghetti code, those are all anti-patterns. People were trying to solve a problem, but going about it in a very misguided way. So that's what's meant by anti-patterns. It's not a good design pattern, it's a pattern to avoid.
Bill, I got to drop off. Thank you so much.
Thank you for joining. Yeah, I'm kind of running long today, quite a bit long, and we haven't even gotten to the practice questions yet. But here, finally, we're at the practice questions, and I'll keep pressing on through some of these. I don't think we're going to get to all of them, but we'll see how it goes. Maybe we can. But here, ponder this and tell me what you think, A, B, C, or D.
Delta?
You like Delta. Use Scrum during system design and a predictive approach for rollout. Yeah, I like that too. So the rollout, it seems logical it would lend itself to a more predictive approach, whereas during the design phase, we're developing a new software application for referral tracking. I think Scrum would be a good way to do that design phase. Yep. So that's the answer I was looking for. Let's just look at the other answers and talk about why they're not good. So A, capture requirements and design the system, then use an iterative approach for training to determine the optimal training approach. Well, it's a judgment call, but I just don't think that the training is going to be that ambiguous. I think the training probably is going to be pretty straightforward. Scrumban, it's a thing. It's kind of some sort of combination of Scrum and Kanban, but I just don't see any reason to assume that that's a good framework for this situation at all. And certainly extreme programming for training makes no sense at all. C, use pair programming for the design and Kanban for the rollout. Well, maybe, but you would need to know more to make that defensible. We don't have enough in the question to make that defensible at this point. So D is the best answer here. But it takes some thinking. It's a little bit of a judgment call. You have to weigh the answers, but that's very typical of what you'll see on the test. The test is not going to be super clear cut. You heard Mary talking earlier this morning about how at the end of the test, when she hit submit, she really didn't know if she had passed or not. And she ended up passing above target across the board. So that just shows you how frickin' ambiguous this test is. All right, so I'm going to tee up question number 2, and I'll let you ponder this, but I'm also going to call for just a 5-minute break. We've been going for over an hour. So I'm going to invite people to get up and stretch, and then we'll come back in 5 minutes to press on. I know I've run long. If you have to leave, I understand, but I want to try to get through this. So let's press on, but take 5 here, okay? I'll see you back in 5. Okay, 5 minutes is up. What do people think about question number 2?
Alpha.
You like alpha pair programming? Yeah, so I agree. So the dynamic of this question says we're doing something really complicated, and pair programming has a fighting chance of helping us do that better. The other answer choices just don't line up with the situation as well. Very good. Please interrupt anytime if you have questions. Otherwise, I'm going to try to go through these pretty quickly to try to get through all of them. On to number 3.
Say C.
You like C, that's what I like too. Scrum iterations to see which advertisements work best. Yeah, very good. So it seems pretty clear to me that those beach umbrellas and flappy hats are intended to be sold together. So we're not really going to be seeing which one sells better. We want to do these cycles of advertising to see what works better, and the Scrum iterations are consistent with that. The other approaches, the other answers just don't line up as well. All of these are judgment calls, but the more you know about the frameworks and their strengths and weaknesses, the better you're able to navigate the judgment calls. Very good. And this is going to be recorded, so you might benefit from reviewing this as a recorded session once or twice more ahead of the test, because I'll tell you, on the PMP test, this agile stuff is really important. All right, on to number 4.
Bravo.
Bravo, very good. Refactor the code, yeah. So this is a dynamic you can almost expect. If you go through 7 sprint iterations, there's a good chance you're going to start accumulating some technical debt, and your progress is going to start to slow down. And once that happens, that's telling you it's time to start refactoring your code. So very good. On to number 5.
Charlie.
Well,
I want to say
ideas?
alpha.
Yeah. This is a real judgment call, but I was thinking of D, delta. My thinking here is just this whole idea of asking people to use this time and attendance system. is inconsistent with Agile. It might be necessary, but if you could shield the team from this, it would be nice. So it's a very simple idea. This is inconsistent with the Agile mindset, and so D is the answer I was looking for. Where the others, like in A, actually velocity probably won't increase. You know, you're pushing them to do more work, but I don't think their work is going to increase by pushing them. In C, you know, actually changing the sprint from 2 weeks to a week and a half is a terrible idea. You really want it to be either 1 week or 2 weeks, or 3 weeks or 4 weeks, because you really want, you know, the same day to be the same practice. You're always doing sprint reviews on Friday mornings, and you're always doing sprint retrospectives on Friday afternoons, for example.
So more of a battle rhythm.
Yeah, that's it. That's exactly right. Coming from a soldier, battle rhythm. That's what I was looking for. Thank you. All right, pressing on to number 6.
Let's say Bravo.
Yep, that's what I was looking for. So the idea here is just that some of the work needed more time. It wasn't fitting into this 1 week sprint. And so stretching it out to a 2 week sprint makes sense. So very good. That's what I was looking for. Next.
Say Alpha.
Yeah, A.
Well, other ideas? If it wasn't A, what would you pick?
C isn't Charlie.
Charlie,
Thank you, Isa. That's what I was looking for. Yeah. So I'm going to say that Scrum is not even the appropriate framework for this kind of project. These data center pod build-outs, the cost of change is very high. There's no place for Scrum here. Scrum needs to be kept in its place, and it's certainly not here. So C is the answer I was looking for. You'll use design iterations early on, which is adaptive, and then we'll eventually get to a predictive approach because the cost of change is just too high to do anything else. Very good. And this also makes the point that adaptive is nothing new. Adaptive in the form of design iterations has been a part of traditional project managers since forever. We've always had phasing and prototyping and so forth. So there's nothing new about adaptive. The only thing that's really new and unique and different is agile, where you put the iterative and the incremental together and surround it with a wrapper of all of this ushy-gushy, touchy-feely, soft people skills stuff, which is easy for me to trivialize as an engineer, but which is just so important for this kind of collaboration type work. All right, on to number 8.
D, Delta?
Yeah, so that's not a terrible answer. It's nice to involve the team and stuff, but it's not actually the answer I was looking for.
B for better. B.
B for Bravo.
Yes.
Yeah, so that's good. I'm actually leaning towards C, which is essentially the same thing.
Oh, yeah.
Let's see, but put in a more diplomatic way. So, we probably don't want to tell the VP of marketing that she's going to be allowed in the room, but she shouldn't say anything. But if we explain to her that certain people are going to be estimating, but she won't be, that's just going to sound a lot better. So that's more
of a respect answer as opposed to.
Yep. Right.
Yeah.
Yep. It's a minor detail, but as project managers, that's one of the things we got to do is we got to preserve our relationships, and certain people need a really delicate touch and a whole bunch of respect because their title is VP of Marketing. That's a real thing. All right, good. On to the next.
Delta?
Will it be Delta?
Well, if you had to choose a different answer, what else would you choose?
B Bravo.
B Bravo. That's what I was looking for. Yeah. So here, the poor product owner is feeling really nervous. He sees things are messed up, and there's corrective actions that are needed, but he's nervous about speaking up because he's afraid management is going to just jump down his throat. They're so stressed out due to these massive financial losses. And this is a very typical dynamic. Whenever a big company gets into trouble, this will generally start to happen, where people lose the sense of being comfortable speaking truth to power, and everybody is crawling into their shell and trying to not be noticed and not say anything and not make any difficult decisions. It's a very dysfunctional dynamic. But as a product owner, you really need to have the courage to say what needs to be said. And if they can't handle the truth, that's just too damn bad. So that's the answer I was looking for. Very good. Next. So this one is a new format. We're seeing some questions on the PMP test now with different formats, and this is one of those match the columns type of things. So let's just take this piece by piece. So A on the left, Stacy matrix, where does that match up to on the right side?
I would say that would support selection of predictive versus adaptive.
Exactly right. Very good. And B, agile?
The first one?
Yep. Combination of iterative and incremental. Very good. And C, iterative.
Delivers value along the way.
Yep. Very good. And D, hybrid.
Combo of predictive and adaptive. I feel that I'm seeing all these.
Yep. Excellent. And finally, incremental, E. Go ahead, Jason. You're not a spring butt.
Supports design collaboration with play.
Yes, you're not a spring butt. You just know your stuff. Excellent. Very good. All right. Good. All right. Yep. That's it.
Awesome. That made me feel better. The first couple of questions I wasn't getting, and that brought the confidence back.
Is it possible to go over just Stacy matrix is a combination of?
So the Stacy matrix is just a framework to think about. Are we predictive versus adaptive? Can we realistically establish our requirements up front, or if that's not realistic, then we need an adaptive approach. Okay.
So it's supportive in nature.
Yeah, it's a framework or a way of looking at things to help us with that question. Predictive versus adaptive. Yep. All right. Number 11.
Bravo.
Bravo, yeah. So we're going to use a predictive approach during construction as opposed to the iterative approach using design. Yeah, used during design. Exactly right. So during construction, the cost of change will be very high, so we need to be predictive by then. And during design, we can go through these design iterations to reach an agreement on a design. Very good. Number 12.
C for Charlie?
Yeah, very good, Abel. Exactly right. So we're looking for which of the following statements is least correct. And all three of the others are not bad. But C is just dead wrong. Product backlog items near the bottom of the backlog, to break those down into smaller user stories doesn't make any sense. Unless they've risen up in priority so that we need to get them sprint ready, it doesn't make any sense working on them. We're going to do work on a just-in-time basis as appropriate. So C is the one that doesn't belong there. Very good. Next.
Charlie.
B, Bravo.
Yeah, so I'm still thinking to refresh my memory on this one. I think I heard a Charlie or two, right? So
yeah,
an agile framework using daily stand-up meetings and Kanban to govern the flow of work items and periodic planning to admit new work items. So the Scrum sprint planning is admitting the new work items, and it's the agile framework with the daily stand-ups, and Kanban is governing the flow of the work items during the sprint. So I think that's a fair representation of Scrumban. And I actually now don't like this question because I don't think you're going to even see a question on Scrumban on the test. It's not one of the top three. So I'm going to write myself a note to question number 13, replace. I don't even like it. It's wasting our time. All right, let's press on number 14.
B, bravo.
Bravo.
Clear documentation over software code. Yeah, you couldn't get more wrong than that. All right, very good. Excellent. Number 15.
C, Charlie.
So C, Charlie has a poison pill in it. What other answer would you pick?
Bravo?
You like Bravo?
No. Yes. I think it should be D. Because
D.
we are supposed. Yeah.
See, the reason why I don't like D or C.
Yeah, I'm going for A.
A. Okay.
Can be A.
So let's see. Sprint planning, A. Sprint planning, sprint kickoff. Now, sprint kickoff there ain't no such a thing. B, sprint planning, sprint review, sprint retrospective, product backlog grooming. So that's good as far as it goes. It's missing the sprint execution, but as far as it goes, it's okay. In C, daily stand-up and then sprint. Well, that's not right. Everything happens within the sprint. And so that's a poison pill. And the same poison pill is in D. So you can eliminate C and D and A. So by a process of elimination, B is the only one that's decent, even though it's missing the sprint execution. So I like D best. But that's an example of a relatively difficult question where you have to compare to find the best one. All right, next.
Alpha.
Well, other ideas?
I said Delta.
Yeah, Delta is what I was looking for. This is that technical debt that was consciously undertaken. I guess they called it strategic technical debt. You wanted to crank out a minimum viable product ASAP, and so you incurred some technical debt on purpose. So that's the answer I was looking for. A is heroic assumptions. Who knows what languages we're using, and in B, maybe automated tools were expensive, but that doesn't really line up with the question anyway. And C either. I mean, you have to make assumptions to get those to make any sense at all. So D is a straightforward, plausible scenario that's consistent with the question. All right, next.
Delta.
Delta. Yeah, very good. So despite your agile mindset and despite all the principles of agile and the preference over working software instead of extensive documentation, the reality is if you're doing medical devices and you're subject to FDA requirements, there's going to be some process documentation that you need to maintain. It might not feel very agile-like, but it is a requirement for that environment, and you just have to accept it. And you can't be naive and assume that agile gives you a license to ignore everything. This is an example where you have to flex and accept that documentation requirement that comes from the FDA because of the industry that you're in. Very good. Kind of common sense, but just in case.
I do have a question here, though. You said both that it's not required, but then it is required. So I'm a little lost at why A is the You're just saying that sometimes it is required.
A is not the right answer. D delta is prepare the process documentation required by internal audit. D delta is the answer I was looking for.
Oh, good. I'm glad I didn't go on with my brain thinking that.
No. Maybe I misspoke before, but D delta is what I was looking for. Very good. We're almost finished. I think we just have two more. Number 18.
Hey, Charlie.
1 and 3. So the project is simple relocation, and 3, the project is very complicated and late changes will be very expensive. So yeah, those are two overwhelmingly convincing arguments to use waterfall instead of agile. I'm spanking myself for using the word waterfall. I like to say process-based or predictive. To me, waterfall is too prejudicial. It's used by people who hate PMI's predictive framework. So, but anyway, C is the answer I was looking for. Very good. Last question.
Yes, Bravo.
Yeah, so the servant leadership is this super touchy-feely, supportive kind of management style where you're supporting your team members in their work and even in their broader career success, super nurturing, and there you have it. And it's something that's talked about in the agile space all the time. And I'm sounding like I'm making fun of it, but actually it's a pretty important type of leadership. And you can think of leadership as this broad continuum from servant leadership at one extreme end and theory X, command and control at the other extreme. And different situations call for different leadership styles. So there are definitely situations where that supportive servant leadership style is appropriate. And so that's the answer I was looking for here. Very good. And that's everything I've got for today. We ran really long. Thank you guys for hanging with me.